let us start a new lecture on general concepts and definitions in metrology. So, in this we will see metrology definition, metrology types, then need for inspection and metrology terminologies. These are very important. Many a times we try to interchange the terminologies, but it gives you completely different meaning. So, there are certain definitions for metrology. It is a field of knowledge concerned with measurements and includes both theoretical and practical problems related to measurement is one definition of metrology. Process of making extremely precise measurement is also a definition of metrology. It is the documented control that all equipments is suitably calibrated and maintained in order to perform its function and give reliable results is also a definition for metrology. It is the science concerned with the establishment, reproduction and transfer of units of measurements and their standards are another definition for metrology. So, metrology can be defined by 4 different ways. The science concerned with the establishment, reproduction and transfer of units of measurement and their standards is very popularly accepted. When we talk about metrology, there are 3 different types of metrology. So, the first one is called as scientific metrology, the second one is called as industrial metrology, the third one is called as legal metrology. What is scientific metrology? It deals with the organization and development of measurement standards and with their maintenance at the highest level is scientific metrology. This is an example of a coordinate CMM coordinate measuring machine, wherein which there is a pump housing kept there. So, this is these are 2 columns, in between you have a bridge. So, this in the bridge you have a arm which is resting. So, here is a probe which is used for measuring the housing pump housing feature details. Okay. So, it deals with the organization and development of measurement standards. So, it follows all the standards what is established with their maintenance at the highest level is a scientific metrology. When you talk about industrial metrology, it deals with ensuring of the adequate functioning of the measurement instrument used in industry as well as in the production and testing process. For example, here it is already drawing is existing, you look at the component, you try to measure the dimensions or deviations from the component and you try to take the result out of it, that is called as industrial metrology. Okay. It is necessary to work with quality in the industrial activities. The difference between this, it deals with the organization and development of measurement standards. So, here you are developing standards with their maintenance at the highest level, but here already pre-existing equipment is there. Using that equipment you are trying to measure and quantify data. What is legal metrology? It is concerned with the accuracy of measurement where these have influence on the transparency of economical transactions, health and safety. So, we try to measure certain parts or certain products which are produced and see how legal it is for allowing the product to enter into the market. Its function is to regulate, advise, supervise and control the manufacturing and calibration of measuring instruments is legal metrology. In this course, we will be more focused towards scientific as well as industrial metrology only. So, there is a word called as inspection. inspection is very important. You have produced a part. So, how do you characterize, how do you evaluate your process? It is only by measurement, right. When we talk about measurement, inspection is a process which is part of measurement process. So, the need for inspection is to ensure components and parts whether they conform to the established standards. There is a drawing available, there is a part which is produced, all you have to do is measure the part and validate as against the drawing and see what is their deviation. To meet the interchangeability of manufacturer, interchangeability is a big concept and interchangeability is a revolutionary concept. In interchangeability, we can most of the interchangeable components fall under some standards, and if you want to meet your manufacturer to produce a part and maintain interchangeability concept, inspection is very much important. To produce the means of finding the problem areas. So, if you start inspecting a part, then you can quickly come and say where is the process mistake, or in this particular part when it is assembled where can the mistakes happen. To produce the part having acceptable quality levels, we always do inspection. For example, people talk about 6 sigma, 12 sigma, all those things. So, acceptable quantity level if you want to check, we do inspections. To judge the possibility of rework of defective parts and re-engineering the process, we need to do inspection. So, if there is a part, see generally what happens, from a raw material you do value addition, you do a machining process, produce a part. This part can be accepted, the part can be rejected, or the part can be reworked. If you want to, if by some means the part falls on the rework category, then we should quickly know how much to rework, what should we rework such that we can make the rework part into acceptable part. So, for this we have to do inspection. To purchase good quality raw materials, tools and equipments, we need to do inspection. So, these are some of the important points which insist that we have to do inspection. Let it be a small product, let it be a pharmaceutical product, let it be a car, let it be a rocket. You see, people try to do different types of inspection. The inspection can be visual, the inspection can be superficial, the inspection can be on the engine, the inspection can be for checking the tires, their alignment, all these things are called as inspection. So, let us see some of the metrological terminology. The first thing what we are going to discuss is accuracy. The closeness of agreement between a test result and the accepted reference values is nothing but accuracy. So, if I want to put it on a figure, let me draw probability density From this figure, it is very clear that the y-axis is probability density, the x-axis is value. So, this is the reference value what you want, and this is the value what you have received or achieved. So, this is the value which you have achieved, this is the reference value. The difference between these is called as the accuracy. The variation is called as the precision. So, the closeness of agreement between the test result and the accepted reference value, and the accepted reference value is called as accuracy. Bias. the difference between the expectation of the test result and an accepted reference value is called as bias. The difference, I repeat, the difference between the expectation of the test result. You expect some test result and an accepted reference value is nothing but bias. The next important thing is calibration. Calibration is done at 2 times, at the beginning and then regularly while running. We always try to do calibration. We calibrate it with reference to a standard. So, a set of operations that establish the relationship between values indicated by instruments and their corresponding values given by standards under specified condition is nothing but calibration. Calibration is make sure that our device, whatever is showing as an output and the standard which is available, you just compare it and see whether it is following any trend. So, calibration is done at the beginning when all the assembly is done, and now we try to calibrate and put the measuring equipment into action. Next is over a period of time, because of wear and tear also calibration is important. Calibration is nothing but a set of operations that establish the relationship between values indicated by instruments and the corresponding values given by the standard under specific conditions. What is confirmation? Confirmation is the set of operations required to ensure that an item of measuring equipment is in a state of compliance with requirements for its intended use. This is confirmation. Confirmation, the set of operations required to ensure that an item, whatever you produce, of measuring equipment is in a state of compliance which will accept with requirements for its intended use. That is confirmation. And next is correction. It is equal to the assumed systematic error. Correction is there is an error. Now, you adjust it accordingly to bring back the system, the measuring device, the instrument back into action. It is equal to the assumed systematic error. We will see what is systematic error in this lecture itself. As the systematic error cannot be known exactly, so correction is subjected to the uncertainty. So, corrections are nothing but okay, we are regularly trying to, we are giving key to the watch, and then over a period of time, because of the mechanical wear and tear, there will be an error. So, for example, initial first few years it will be every 24 hours you do, and over a period of time you try to do it for every 20 hours. Then slowly it will come down. So, those things, a variation is from the exact value is called the error, and systematic error is we know what is the reason, and the error gradually decreases over a period of time. As the systematic error cannot be known exactly, so correction is subjected to uncertainty. Drift. Drift, the English word drift itself very clearly says a slow change of metrological characteristics of a measuring instrument is nothing but a drift. So, let us, so we will take sensor output, and then here it is measure, MEA, measurand, okay. And then what we do is here okay, this is the sensitivity drift. This is the total error due to drift. Okay. This is the best fit straight line at initial calibration. Okay. Then this is zero drift. So you can see initial, and this is at total error. Okay. So this you can see as and when the measurement it keeps going over a period of time, the sensor output there is always a drift. This was the initial one, and this is the final one, and you see a drift in the center. So this is called the best fit straight line after zero drift, after making a correction. Okay. So these are some of the terminologies. Okay. So you have zero drift, you have span drift, you have combined drift. So we will see that one after the other. So what is zero drift? Zero drift means it is output, this is input. So this is a drift, zero drift. Okay. This is zero drift. So this is the drift which happens when the starting point is there, and there is a drift which has happened here, and almost the slope is almost constant. This is zero drift. So next is span drift. So span drift is nothing but output, this is input. So you have this one is the normal thing what you have, and this is what is a span drift. So this is span drift. If you look at it, so if you want this is zero drift. Okay. So the combined drift is nothing but a combination of these two. So this is output, any output, it can be any variable. This can be an input variable, okay, and this is something like this, and this is what is your normally what you get. This is called as combined drift. So a drift is an offset from the center. So that is zero drift. So you will have different types of drift, zero drift, span drift, or a combination of these two. So this is a drift which is zero drift, this is a span drift, and this is combination drift. So when we talk about error, what is a error? The indication of measuring instrument output minus the true value of the input quantity is always the error. So you look at it, here is the here is the measurement. So true value somewhere is in the range. So here is a true value. So here is the result whatever you get. The difference between these two is nothing but the error. Okay. It is otherwise called as accuracy or uncertainty. These are this is a true value whatever is there. So the indication of a measuring instrument output minus the indication of the measuring input measuring instruments output minus the true value. So this is the error. So we get a data here, this is the true value, and here is the error what we get. What is expectation? The mean value of specified population of measurement is called as expectation. What is fiducial error. The error of measuring equipment divided by fiducial value specified for the instrument is nothing but the fiducial error. Fiducial value can be the span or the upper limit of the nominal range of measuring equipment. So, the fiducial error. So, the error of measuring equipment divided by the fiducial value which is specified on the equipment, on the instrument. What is inspection? As we already saw, it involves measurement, investigation or testing of one or more characteristics of a product. So, we are now seeing lot of terminologies. So, let me quickly recap what are the terminologies we saw. We saw accuracy, you can remember reference value, original value, we saw accuracy, then we saw bias, then we saw calibration, then confirmation. Confirmation is nothing but a set of operation required to ensure that an item is of the measuring equipment is in the state of compliance with requirement of its intended use. Then we saw correction, then we saw drifts. There are three different types of drifts. One is zero drift, span drift, and then it is a combination drift we saw. Next one was error. So, we saw the definition for error, then expectation, fiducial error and inspection. So, further moving on, magnification. The output signal from a measuring device is to be magnified many times to make it more readable is magnification. And what is measurand? A particular quantity subjected to measurement is called as measurand. So, a particular quantity subjected to measurement is called as voltage, temperature, then you have length, meter. So, a particular quantity subjected to measurement is called as measurand. Then we will see what is nominal value, the approximate value of the measuring instrument that provides a guide to use it is called as nominal value. There is a big interchangeability we use between precision and accuracy. What is precision? The closeness to agreement between the independent test result obtained under stipulated condition is nothing but precision. The closeness of agreement between independent test results obtained under stipulated condition is nothing but precision. So, what is range? So, range is the capacity within which the instrument is capable of measuring. For example, it can be 12, 25, 27, 29, 36. These are some of the values what I get out of the measuring device. 43, then 50, 54, then 62, then 27. So, if I see the range, what is the range? The range is nothing but from the lowest to the highest. It is 12 to 62 is the range which is there in this particular measuring device. So, these are some of the units. It can be voltage, it can be millimeter, whatever it is. So, we are just trying to find out or trying to explain what is the range. The capacity within which the instrument is capable of measuring is called the range. What is readability? Readability, it refers to the ease with which the reading of a measuring instrument can be read. The readings, for example, if the graduations are too thin or too small, then you can't read it. Readability is also very important. What is reference value? The value with which agreed, the value which agreed on reference of for comparison is called as reference value. If you go back and see, we have already talked about reference value. So, the value which agreed on reference for comparison is nothing but the reference value. Next, repeatability condition. Whenever independent test results are obtained using same method, items, place, operation and equipment within short interval of time, it is a repeatable condition. Repeatability is very, very important, because when you try to measure an object repeatedly 20 times, if you get varying result, then the repeatability becomes a question mark. Okay. Reproducibility, the precursion under reproducibility condition is reproducibility. Reproducibility condition where the test results are obtained using the same method, item, but in different place, operator and equipment. Repeatability condition wherein where independent test results are obtained using the same method, item, place, operator, equipment within short interval of time is repeatability condition. What is reproducibility condition? Where the test results are obtained using same method and item, but in different place, operator and equipment is reproducibility condition. Please try to understand the difference between repeatability and reproducibility conditions. What is repeatability? If I have to plot it again, this is the master value. This one is the, you will have mean, this is the mean, this is the mean. So, which of the two conditions are good? This is good, good repeatability. This is poor repeatability. You see, the mean is becoming larger. The mean is at the center, the variation is becoming larger and larger and larger. This is poor repeatability. So, that means to say there is a variation for the same machine to produce a shaft. There is a lot of variation in the values in the shaft which is produced in terms of length and diameter. Here it is almost very precise. So, this one is called good repeatability and this one is called as poor repeatability, where you see a huge spread from the mean is there. What is response time? The response time which elapses after sudden change of the measured quantity until the instrument gives an indication. So, response time is I give you a command, how quick you respond, or you try to send, there is a change in the measuring device or the measurement value. If there is a change in, and how quickly this change can be responded or this can be recorded. The time which elapses after sudden change of the measured quantity until the instrument gives an indication is nothing but response time. What is resolution? The smallest change of the measurement quantity which changes the indication of the measuring equipment is or instrument is nothing but resolution. The smallest factor, for example, if you have data 10, 11, 12, 13, 14, the resolution is 1. Let us assume these are all values. The smallest change of the measured quantity which changes the indication of a measuring equipment is nothing but resolution. Then sensitivity is very important. The smallest change in the value of the measured variable to which the instrument can respond is called as sensitivity. Very important definition. So, this is also very, very important. Response time, resolution. These are all very important. Stability. Stability is also very important, because suppose when you try to use a voltmeter or when you try to use an ammeter or when you try to take a device and you want to measure it, if as soon as there is a change in values, it will start vibrating or it will start fluctuating or it will start running with numbers. So, it takes some time to find out the stability. So, the ability of measuring instrument to constantly maintain its metrological characteristics within time is called as stability. Standardization, the process of formulating and applying rules for orderly approach to a scientific activity for the benefit and with the cooperation of all the concerned in particular is nothing but standardization. Standardization means we make standards and you make sure that your product is to that standard. So, standardization, the process of formulating and applying rules for orderly approach to a specific activity for the benefit and with the cooperation of all the concerned in particular is nothing but standardization. The next one is testing. Testing is nothing but a technical investigation to know whether the product fulfills its specific performance is testing. Then traceability, you have got some data, You want to trace it and find out when was this generated, what is it. So, traceability means that a measured result can be related to a stated reference is nothing but the traceability. What is trueness? The closeness of agreement between the average value obtained from a large series of test results and an accepted reference value is nothing but the trueness. It is usually expressed in terms if biased. So, trueness is nothing but closeness of agreement between the average values obtained from a large series of test results and an accepted reference value. What is uncertainty? It is a parameter associated with the results of a measurement that characterizes the dispersion of values that could reasonably be attributed to the measurement is uncertainty. Characterizes the dispersion of the values that could reasonably be attributed to the measurement is nothing but uncertainty. It can also be expressed as an estimate characterizing the range of values within which the true values of the measurement lies. Uncertainty. When specifying the uncertainty, it is necessary to indicate the principle on which the calculation has been made is uncertainty. When specifying the uncertainty, it is necessary to indicate the principle on which the calculation has been made. So, this is uncertainty. So, this is the mean, this is mean minus standard deviation, mean plus standard deviation. This is the true value. The difference between the measured mean and the true value is nothing but the error. Uncertainty means from here to x plus y you have something called as uncertainty. What is uncertainty? Uncertainty is the parameter that is associated with the results of a measurement that characterizes the dispersion of the values that could reasonably be attributed to the measurand. This is uncertainty. Verification, an investigation that shows the specific requirements are fulfilled is nothing but verification. Standard is a level of quality or achievement, especially a level that is throughout to be accepted is standard. Group standard, a set of standards of chosen value that individual or in combination provides a series of values of the same kind is called as group standards. Workpiece is known. Instrument is a tool or a device that is used to do a particular task is called instrument. Environment, external conditions or surrounding, especially those in which the people live or work, is called as environment. So, this is also very, very important. So, to recapitulate in this chapter, we saw different definitions for metrology. We saw different types of metrology. What are they? They are scientific, industrial and legal. What is the need for inspection? Yes, we saw, and we saw various terminologies in metrology, which is very, very important. Various terminologies we saw. Okay. So, the task to students, let us see two tasks. One is, I want you to cook tea in your house. Okay. So, what I want is every day the output of the tea, is nothing but the taste. You are supposed to measure the output of the tea, that means to say in terms of taste, for varying days, maybe 1, 2, 3, 4, 5, 6, 7. For 7 days you try to do, and 7 days I also want you to do one more exercise and see how do you placement of shoe in your shoe stand. That means to say location. We are talking about location. Okay. Which location do you place your shoe every day? For 7 days you have to see, measure or try to have some data how you can measure the location of your placement. So, I want you to do it for 7 days. So, what is the reason of doing this is you will try to see how repeatable is your repeatability of your process. You will never get a mean, you will always try to get a mean with a variation. So, this is the variation. Okay. Next thing, I would like you to measure few vegetables like carrot, tomato. Try to take tomato, maybe 1, 2, 3, 4 and 5. Try to measure the diameter and see what is the variation. And in terms of carrot, try to take carrot by 1, 2, 3, 4, 5. Try to measure their aspect ratio. Aspect ratio means it is length by diameter. So, measure it and then you start reporting it. When you do these two things, you will try to see that repeatability, and then you will also see how reliable is your data. Reliability, repeatability, reliability, and then what is your sensitivity of your measuring device, and then how sensitivity, and the geometry is complex, how do you choose your measuring device. And those of who are not having a vernier caliper, the easiest way of measuring diameter is try to take the tomato, try to take a rope or a twine, just wind it around, snip it off and then try to measure the length. So, you have length and then from here you can try to find out the diameter. So, you can do this and try to understand. So, when you do these two exercise for yourself, you will try to realize, if at all I have to choose a instrument for measuring, how will I choose? Then whatever data I get, is that data going to be constant or is it going to be varying? Then you will also understand the concept of, so the value falls within which range. Then you will also have to realize one more definition what we studied is the stabilization. Okay. Some devices, first time I measure, I will not be able to understand. I do from 2-3 times, understand the process, and then I try to figure out how stable is the process. So, if you go through this, these two examples, many of the definitions what we discussed in this lecture, you will be able to appreciate their necessity and their significance. Thank you very much.